Welcome back to Advent of Code 2023, day 24, which opens in 1 minute. Get that light up there. Still haven't finished day 21, maybe today, hopefully today. Alright. Just a few seconds to get my coffee quickly. Didn't have time. Let's read a bit, then I'll come back to it. Go back to get my coffee while I think. Alright, so day 24. Ooh, 3D stuff. It seems like something is going wrong with the snow-making process. Instead of forming snow, the water that's been absorbed into the air seems to be forming hail. Close enough. Maybe there's something you can do to break up the hailstones? Actually, no, hail is actually really painful when it's heavy. Due to strong, probably magical winds, the hailstones are all flying through the air in perfectly linear trajectories. You make a note of each hailstone's position and velocity. No acceleration? Okay. Each line of text corresponds to position and velocity of a hailstone. After 1 nanosecond, okay. Yep, I get that. How likely are the hailstones to collide with each other and smash into tiny ice crystals? Looking forward in time, how many of the hailstone's paths will intersect within a test area? In this example, look for intersections that happen with an X and Y position at each at least 7 of... Okay. In your actual data, you'll need to check a much larger test area. Okay. However, you'll need to search a much larger test area. Blah, blah. Look for intersections that happen with an X and Y position, each at least... Okay. Disregard the Z-axis. Alright, so we're finding... So we can just check the... We can check the paths they're following. Find the intersection point. For all pairs. So that's like, I don't know, probably 1 million intersection points if they even exist. And then just check. Because two hailstones can only intersect once, right? Only crash once. But wait. But if two hailstones crash, then will they keep going? Because then you're preventing a future crash, aren't you? Oh, okay. They don't have to collide, just test for intersections between the paths they will trace. Okay, fine. Yeah, this is just basic physics simulation. We can just brute force it. Well, not brute force isn't. I should stop using the term brute force because it's kind of misleading sometimes. In this case, just simulation, step by step. Brute force doesn't even make sense. You're not solving a decision problem. You're simulating something. All right. Okay, it's an easy part 1. Where's my input? Okay. At... Okay, fine. Wait. Oh, so those are the velocities. Alright. Alright, let me give a copy. Okay, so we can use our pos class that we've been using for the last several days. That everything's been kind of spatial the last few days, which is nice. I like spatial problems, but okay. So we've got pos, but it's gonna have to be XYZ. Right, and then velocity will also be a pos. Okay, so we've got hailstones equals list, and we want okay, so it's gonna be, let's say left, so it's gonna be position velocity equals line dot strip dot split. Let's do at space at space. So that gives us the two parts, and then pos equals pos, so it's going to be star int k for k in position dot split on the comma space. I mean, we can also just do, let's do, I like doing it this way, map int position dot split space. All right. And that passes those into the pos, and velocity equals so yeah, okay, fine. Hailstones dot append. Do we just for now just put the pos and the velocity like this? Okay. So what do we do to find the intersections? All right. Wait, we're not looking for integer intersections, are we? Oh no, no, they could be floating points. Interesting. Okay. So, I've got to remind myself how to do these equations. So, oh, what's this? Unexpected argument. Oh yeah. Hello, the Four Fox. Welcome. We're doing some physics simulations. Simulating hailstones as they travel through space. This is going to have to be self.x plus other.x. Oops. Self.y plus other.y, self.z plus other.z. Okay. Okay, so for... Have you been? I've been good. Yeah. This month I've been very busy programming, like every day a few hours because of this advent of code. So it's not really a holiday for me. This is actually one of the... Because of advent of code, it's one of the busiest times of the year. That's all thanks to Eric Wastel, who made this site which lures us in. But it's the final 2 days now. I'll finally be free after tomorrow. So I want for so for I in range, for I H in enumerate hailstones, or J K in enumerate. So just get a pair of every pair of hailstones. Actually, no, just do... Just create a variable here. Alright, write this again. I in range n for j in range. So starting from I plus 1 to n. So that way we don't double everything. So I'm a little behind. I've missed the last 2 months worth of streams. What are we making? Each day a new puzzle is released and we write code to solve it. So today is this puzzle here. It's easy to describe. Basically, we have a set of positions here. So these are the coordinates of a bunch of hailstones, and their velocities, XYZ, XYZ. We have a whole bunch of them. Right now, the first part, we're trying to find where they collide, and whether they collide within a certain region. So I'm just checking every pair of hailstones and determining where they collide. So if you know position and a velocity, then you should know where where two hailstones would collide, if they collide at all. Well, they will collide. Well, it's just whether... Well, okay, let's finish coding this. For J... Alright, so pos 1 vel 1 equals hailstones I. Pos 2 vel 2 equals hailstones J. So we've got these two hailstones. All right, where do these lines intersect? I forget the formula now. So it's... So you're taking the easy way out, as opposed to... As opposed to what? This is how you would do it, isn't it? How else? So... I can't remember how to do this. Okay, so I need to write some algebra here. The new position of hailstone 1 will be the original position plus lambda times velocity 1. Alright, maybe I should write out some formulae here. So P1 equals pos1. This is not Python code. Plus, I don't have lambda, let's just say R times vol1, okay. P2 equals the original pos2 plus T, actually, these are times T times vel2. T has to be the same for both of these because we want them to collide at a certain time. Okay. So, but we also want the position to be equal. So basically, pos1, said you were brute forcing it, didn't you? Did I use that term? But I mean, what would you do that isn't brute forcing? You said easy way out, so what would the hard way out be? I don't know, I'm not sure what you mean. Okay, so pos1 blah 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 equals that. Now what? We can work out T from this. So I was making a joke about you not spending 2 weeks doing it in a super efficient engendered, you mean engineered way? I mean, for part 2, we probably would have to do it in an efficient way. I don't know. Okay, so these problems have a part 1 and part 2. Part 1 is usually the easy one. So you can just throw together an easy for loop or something. That's what I'm doing now because the emphasis is to complete it as fast as possible. So it's better to do like a big chunky for loop than something smart. But then for part 2, they probably will introduce something that you need to be efficient for. And that's the bit I'll spend hours on because you kind of have to. So we'll see. It depends what part 2 is. Right, so this gives us T equals, so it's going to be pos2 minus pos1 divided by vel1 minus vel2. Right, so this is the time at which they collide. Right. In the XY position. This doesn't even make sense. You can't divide by... Oh, these are vectors. Whoops. Oh, but that's fine. We can do the x and then the y separately. Okay. Okay, so we get the t by finding where their x coordinates meet, right? Now, if they're parallel, then this will be infinite, so we need to watch out for that. Okay. So, alright, so... So we want to do... So it's basically the x values. That'll tell us where they meet, because... Alright, so, if vel1.x is vel2.x, that means they'll never meet because their x velocities are the same. So they're always going the same amount in the x direction. They can never actually collide. Okay. So we need to skip these ones. They won't collide. Alright. So if they're not equal, then we're able to do this. T equals pos2x minus pos1x divided by vel1x minus vel2x. Okay, that's where they meet. And we want to check that the y position. We want to check that the y position is going to be the same at this point. So basically, we're trying to make T1, we're trying to check that T1... Oh wait, we want to do the same thing for vel2.vel1.y equals vel2.y, because if that happens, they also won't meet. Otherwise, we're doing... so it's basically this. 2.y, y, y, y. We want to check that T1 and T2 are equal. Now, this is floating point numbers. We don't like to check... we don't like to check equality of floating point numbers because that's kind of a weird thing in programming. So we actually can just multiply both sides. So say this times... Apologies for not giving you ad revenue for a while. Been busy having a girl I've been seeing for a while move in with me. No apologies needed. That's totally fine. I hope you're having a good time. That and Twitch never sends notifications. Yeah. Yeah, Twitch is not great for discoverability. Equal, if this equals, so it's going to be this times this. Alright, if this is true, this big chunky formula, that means they will collide in the XY axis. So, what do I want to do now? I want to check where they collide and check that it's actually within the bounds. So basically, the time they collide, we don't need this, is this. And we want to check. That's pretty much all I've been doing the past while. What about yourself? What, the past few months? Not much. I've been, past month I've been doing a lot of programming. Before that, I was, been doing some Wheel of Struggle, which is a new thing that I'm doing, which is like a bunch of friends, each week somebody nominates a game that we have to all run as a challenge, and the challenge is to, like, I don't know, compete on who can get the furthest in the game within 5 hours or something like that. We've played some... It's good because it kind of forces me to play games I don't normally like to play, like Super Mario Kart, for example. Well, I like Super Mario Kart, but I'm not good at it, but so I don't normally play it. So that's been pretty fun. It's made me play like platformers. I hate platformers now, but it's good to still play them. T. What do I do with this T? Oh, now we want to check if it's inbounds. So yeah, that's the Wheel of Struggle is on break now, but then in a couple of weeks I'll probably be back to that. The last Wheel of Struggle was Doom, so I had to replay Doom 1. Which is cool because, like, Doom 1, I just kind of... I know it's a great game, but I just sort of, every time I want to play it, I'm like, eh. But then I played it, and then I realized it's actually really... The map design is actually really well done, and it really holds up against a lot of modern games as well, so... I always assumed I wouldn't like the old mechanics, but... They are pretty good. You gotta have mouse look though. So I'm using an engine which adds mouse look so you can shoot up or down. In the original Doom you couldn't shoot up or down. I need to put these bounds in. Let's see, B1, B2. Alright, so we want to check... T equals that. X equals is going to be P pos1 dot x plus T times vel1.x if, and then finally, if b1 is less than or equal to x, which is less than or equal to b2, is it strictly within? I don't think it matters. They're not gonna collide right on the boundary. I think it's unlikely. I think it's probably designed so that that won't happen. So if they are within the bounds, what do we do then? Oh. Ooh, T could be negative. In which case, that means they collide backwards in time. We don't want that case. If T is less than 0. Continue. So we only want forwards in time. Alright, so if y equals y, 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 and then we want the y value to also be within these bounds. What do we do with this? Just add 1. We just count how many of these we see. Alright, I've written a huge bunch of formulae, so I'm sure there's mistakes. Let's see what happens. Let's clean this up a bit. Alright, run it. Part 1, 0. Wonderful. So it thinks nothing ever collides. Do we at least get something here? Well, that's interesting. We get one pair that collide. Vel1 dot. So we think one pair collides. There's got to be more. Alright, well, there's probably something wrong with my formulae. Alright, we're going to have to test it on the test example, of course, because these numbers are too big for me to really manually delve into this. So, this example. 12, 31, 28, 20, 19, 15. So, it says these two collide. Hang on. This is suspicious. Because we should very regularly, they should almost always have an intersection point. It just may be backwards in time, it may be forwards in time. What's going on here? Oh! hang on. This line is nonsense. Why did I write this again? Oh, hang on. No, we don't skip. If they're equal, that means hang on, let me take this out for now. I think I've not got the equations right, so let's think. If well, it's still hang on, what happens if the velocities, the y velocities are the same? That's fine. That's perfectly fine. That's not an issue. But it makes this redundant because oh, I've made a mess of this. I can't write equations in code. It's a bit I need to write equations with my hand, then I'll figure it out properly. So trying to find the time where the two lines cross, and then I want to see if where did I get this equation from again? I don't think this is right. It's got to be something else. Hang on. So as I said, T1, the time. See, I cut out all the stuff I had before. I need to put it back because let's just write it out again. So all right. So my position is pos1 plus, let's say, t times vel1. Alright, p2 equals pos2 plus t times vel2. Alright, so that's formulae for my positions, right? So that is where we are at a given time. We want P1 equals P2. So that equals that, right? At the same time. So T is the same in both cases. We're trying to find a T such that this is true. That resolves to two equations, right? One for the x, one for the y. So we want that x dot x dot x, and then we want that y, 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 y. Okay. And then I said, oh, and then I set the t's to be equal. So I think, all right, I see the problem. The problem is when the velocities are equal, you have to handle it separately. So, all right, so if the velocities, the x values, the velocities are equal, excuse me, then it would actually be this would just be vel1.x. These would cancel out. All right, and then pos. Then this will only be true. So we can only okay, I see. If the velocities are equal and the positions are not, then it's impossible. They can never meet. But if the velocities are equal, then and the positions are equal, then that equation is pointless. So then the time that they meet will be all right. It's a bit confusing. All right, I think I know now. Basically, we need to first we handle this case. All right. So if the y's and the x's velocities are the same, right? Then we continue. All right. If otherwise, if this is the same, but the y's are not the same, all right, we've got so if the positions are not the same, then they can never meet. Otherwise, we know what the t value is going to be. It's going to be pos1.y minus pos2.y. Oh man, this is way more complicated than I realized. There's probably a cleaner way of writing this all. Probably numpy is the way to do this. Divided by vel2.y minus vel1.y. Alright. So that's when they meet. Alright. else you know what? We don't even need to do this. It will be handled. Okay, so we get the time that they should meet in theory. But now we check it whether they actually do meet. Alright, so we get rid of all this. Alright, so get rid of that. Alright, now. Okay, so we've worked out where they, at the time, where they should meet. But now we check whether they actually will meet there. So the X position will be there, the Y position will be... Alright, so we want to check that they meet, so... if... So the X position of pos 1 is equal to the X position of pos 2. But this is floating. Oh man. Do we really want to do floating point comparisons? We'll see if it works, but I don't think it will. Otherwise we have to do integer stuff. Alright, if that is that. And that the Y values are the same. Okay, this confirms they are at the same place. At a positive point in time. We might have to use floating point, write our own floating point comparator. Then, lastly, we just want to add them if they are within bounds. Okay, is that gonna work now? Nope. What is wrong now? So if they have the same velocities, then the exact same velocities in X and Y, then they'll never meet in the X and Y, unless they are already in the same place. And if they are, then that's weird, because they're both... I don't know what's going on there. Okay, so... Otherwise, so we skip that case. So then... Oh, I bet it's the floating point is the problem now. Alright, we can fix that. Just use 0? Which one's that? So they're saying these meet at time 0. Come on. Oh. No, it's saying... What? That doesn't make sense. T equals that divided by Oh yeah, no, that's right. That's just where the x's meet. Sorry. Okay. I should probably say greater or equal to 0. Okay. Now what? Yeah, I do think we need floating point comparators. I mean, this would be... The better way to do this, really, is to use integers. So, but then you'd have to rearrange the equations. So you'd have to do t... So t times velocity 1x would actually be... Alright, we'll use floating point comparisons. How do you compare floats? You have to... We need Oh, I've made a mess of this already. So we need the absolute value of a minus b is less than or equal to 0.12345, like that. That's basically it. So where am I doing absolute values? So we're doing floating point equal that, and floating point equal that. Is that the only place I needed to do that? Now what? Alright, well, we can run through one of these and see what we get. So they said... Wait, what? 1913, 30, 18, 19, 22. Should cross inside the test area. Oh, because I've got the wrong bounds, because they didn't put it in the input. So what was the bounds for the sample case? 7 and 27. Still not. Okay, so fine. Now print t. So t. So these two, 19, 13, 30, and 18, 19, 22 collide at t equals 1. Is that correct? Put the x and the y. $17, $14. No, what? We got a really nice number, but it's not the right number. It should be 14.333, 15.333. How have I screwed this up so much? +1, +2. At t equals 1. The t value's wrong, because that's probably where they end up at t equals 1. Why is t even an integer? It shouldn't be. Excuse me. pos1.x minus pos2.x divided by vel2.x. Excuse me. All right, let's do this by hand. So, we're saying t equals... Okay, so in the first case, the neither of the velocities are equal. Okay, so we default to this one, the x's. Okay, so pos1.x minus pos2.x is one, and vel2.x minus vel1.x is 6. So it should be 1 in 6? Why is it 1.0? Is this not how... Print 1 divided by 6. It should be that. T equals... Heck. 1.0? What? Was 1.x plus 2.x. Hello, Herford Bull. Am I late to the party? Not at all. I'm making such a mess of these equations. We're doing a physics simulation, and this is still part 1. T equals pos1.x minus pos2.x. Hang on. Pos1, pos2, vel1, vel2. Pos1, pos2. So the top half of this should be pos 19 minus 18, which is 1. And the bottom should be minus 1 minus 2. Huh? Oh no, that's right. Minus 1 minus 2. So that'd be 1. Oh, that's correct. Where did I get... Oh, I get it. Okay, so that's correct. That's the correct time. So where would they end up at that time? The x value would be 19 minus 2, so 17. X equals 17. So... time, position, 17, and the y value would be 13 plus 1, 14. That's correct. But they're saying it should be 14.33, 15.33. I'm so confused, but... Hang again. Oh, but the second hailstone will be at the same place. So is this t value wrong then? So that'd be 17, 14. Where would the second hailstone be? 18 minus 1, 17. 19 minus 1, 18. I don't understand. Oh no. Okay, I didn't understand the description. You don't care about them meeting at the same time. Oh my god. The words are so confusing. How many of the hailstone's paths will intersect within a test area? Oh, so they don't have to intersect at the same time. This is such a mess. Alright. So we found... Oh, I see. It's already 1 hour. Okay, let's redo this then. Okay, so... we don't want this, basically. Or at least we want a T1 and then we want a T2 here. Okay, so... So if there's an intersection point, which there probably always should be, then, unless they're parallel, then these two will be equal and these two will be equal. Okay. And we know these numbers. So it's simultaneous equations we need to solve. So, okay, so T1 equals so it's going to be vel 1.x minus vel 1.y times T1 Okay, we just have to rearrange this. Let's put this... And I would have been done in minutes if I was writing this all on paper, but I want this to be kind of like visible. This should be a minus. Alright, so it's going to be like that. So we will have vel1.x minus vel1.y times t1 equals, so it's going to be pos2.x minus pos2.y okay. Minus pos1.x plus pos1.y plus, and then it's going to be vel2.x minus vel2.y times t2. So what happens here? So the cases are, if the velocities are equal, wait, no. Yeah, okay. So T1. Wait, but what? Why would we care if the velocity... Oh, I see. So if the velocities are equal, then we immediately get T2 unless those velocities are equal as well. Why would it... Oh my god. This, I can't think like this. I need to write on paper. Alright, I'm gonna get some paper and it won't be visible on stream, but I can't try to use code like this. It's so stupid. See, now if I do it on paper, I'll be able to solve it in minutes because that's the way you do it. Where's my paper? So we have the equation of the first hailstone. So position is pos1 plus t time, it's t times vel1. Okay, p2 equals pos2 plus t times vel2. All right. So we want to find where their positions are equal. All right, so we want P1 equals P2. So that means pos1 plus T times T1 times vel1 equals pos2 plus T2 times vel2. All right, so that's a thing. And that splits into two equations, so x1 plus t1 vx1 equals x2 plus t2 vx2, and y1 plus t1 vy1 equals y2. So far this seems to corroborate with what we wrote already, right? Now, I think the bit which I messed up is trying to solve these simultaneous equations using stupid Python comments. So I'm trying to find the values of T1. Okay, so x1 minus y1 plus vx1 minus vy1 t1 equals x2 minus y2 plus vx2 minus vy2 t2. Okay, so far so good. Now, what I don't understand is if the velocity x and the velocity y are the same, why would that matter? Okay, so that cancels out the t1s, and then t2. I think I've written this all wrong. But at least we know we are dealing with different times and not just Alright, okay, no, maybe it's alright. So we have to handle the cases. If vx1 equals vy1, then we immediately get t2. T2 equals this basically, because of the parallelization, if they're parallel they'll never meet. I think this is the problem that's messing up our equations. Okay, fine. If the velocities are equal, then t2 we immediately get as x1 minus y1 minus x2 plus y2 over vx2 minus vy2. And all right, so let's just write down what we've got so far. So if damn it, I can't. All right, make some space here. Okay. All right, so I mean, we know that the gradient, if the gradients are the same, then they'll never cross, right? Let's cancel. Let's take this out of this. Take this situation out first. All right, so if the gradient is always going to be y, so v y2 over vy x1 x2 equals v x2 v1 over v x1. Okay, so if so it's going to be velocity 2 dot y times velocity 1 dot x is the same as velocity 1 dot y times velocity 2 dot x. All right, then we continue. That's the case where they never meet. Okay. All right. Otherwise, all right, so if vel 1 dot x is vel 2 vel 1 dot y, in this case, then t2 equals it's going to be x, so say pos 1 dot x minus pos 1 dot y minus pos 2 dot x plus pos 2 dot y divided by vel2.x minus vel2.y. And we know that right-hand side can't be 0, because if it was, along with that, then that the gradients would have been the same. All right, so that's fine. Okay, t2 equals that. t1 equals, so t1 will be x, so it'll be x pos2.x plus t2 times pos vel2.x. All right, and all of that minus pos1.x, and then all divided by the velocity of x1. All right. Velocity 1.x. And we know that won't be 0, because then that will also lead to that situation again. So that's fine. All right. Otherwise, T1 is just, it's going to be similar to this, but we do x1 minus, so it's going to be all right. So it's this that. So it's x minus y minus x plus y2 plus, and then we've got oops, I forgot to scale one of these. That was the problem. I get it now. I get it now. All right. I forgot how to solve simultaneous equations. This is basic GCSE stuff. I didn't scale them correctly. That was why we have this weird situation. Okay. Let me just write that down, and then we'll rewrite it in code. All right, so it's Vy1 times 1 minus Vx1 times 2. Okay, so that gives us Vy1 these letters are terrible. I should have used different letters. Now I just can't. Okay, all right. I can finish this off. We don't need to do, in fact, all this could be removed now. Okay, so it's going to be Vy1 times x2 minus x1 minus vx1 times y2 minus y1 plus t2, so it's going to be v y1 vx2 minus v x1 times v y2. Okay, there we go. So t2 equals vx1 times y2 minus y1 minus vy1 times... Oh my god, I'm so glad I didn't try to write this in Python comments. This is horrible. All over vy1 vx2 minus vx1 vy2, and there it is. There's the gradient formula. So yeah, that's checking that gradients are not equal. Okay, this is correct now, finally. All right. So we check the gradient, and then don't do this silly thing here because that made no sense. All right. T2 equals, so the top half is v, so it's going to be velocity 1.x times pos 2.y minus pos 1.y minus velocity 1.y times pos 2.x minus pos 1.x. Yep. And then all of that divided by the gradient, which is going to be velocity 1.y times velocity 2.x minus velocity 1.x times velocity 2.y. Alright, if there's even a single letter wrong there, then it's going to be wrong. Alright, T2 is that. And then once we've got T2, then T1 is simply, this is easy, just do T1 equals but we need to check cases. Okay, if the velocity 1.x is 0, then we have to go to the second equation. So T1 equals, so it's going to be pos 2.y plus T2 times velocity 2.y minus pos 1.y divided by velocity 1.y, and we know they both can't be 0. Else we just do the same but with the x's. Okay, we know velocities can't both be 0 because then what? It's not moving. Are we allowed that? Are we allowed the not moving? Well, it's probably never going to happen. Okay. Yeah, you're allowed to not move, but then... Whatever. Okay. Okay. So now we've got T1 and T2. Alright. Just get rid of all this. No, not everything. Oh my god. Now, this will probably be easier if I had some vector addition methods and stuff, but whatever. Alright, we've got T1 and T2. Alright. Doesn't matter if T1 and T2 are equal, but we do need them to be positive. So if T1 is less than 0 or T2 is less than 0, continue. Alright, if they collide backwards in time, then we're not interested. Okay. So now we want to see the intersection point, whether it's in bounds. So the intersection point, x equals, so it's going to be cos 1.x plus t1 times vel 1.x. And then y will be the similar. We could just use plus 2, 2, 2. Okay. If okay, b1 is less than or equal to x is less than or equal to b2, and b1 is less than or equal to y is less than or equal to b2, then total plus equal. What a mess. I bet it's still wrong though. Let's get rid of all this. Like, I've got it on paper, that's good enough. Two for the sample. Yes. Oh my god. Can't believe I made such a mess of that. Simultaneous equations. Can't remember the last time I did this. Probably it was for another advent of code. Alright, so now just do this. Except not for this example. There we go. 20522, please. I don't have to recheck all my algebra. My naming was terrible. That was the main problem. I couldn't think of the... Too high? Damn it. Okay, let's check that we're getting the right x and y values then. It's probably an easy fix. At least that, and at most that. Just put some comments so I know what I'm... Alright, I'm curious. If pos1 is pos2, print pos1, pos2. Oh, well, they'll be the same. Does this happen? No, it doesn't. Okay. I was wondering if they've given us a trick one where they actually they're in the same place with the same velocity, so two particles in the same location, but that's not the case. Okay. So we skip the ones which have the same, which are parallel. How often does that happen anyway? Four times, not that many times, but it happens. Okay. Otherwise, we work out this using this big old equation. And if either of them are negative, then okay, so we've got two lines. We find their crossing point. If they're parallel, we discard them. Otherwise, there is a crossing point for sure. And we want t values for when the particles reach those locations. Now, if either of them negative, that means it was backwards in time. So we only want ones where they meet forwards in times, or they cross that point forwards in time. X equals that, Y equals that. Oh, for goodness sake. That should be Y and that should be Y. Okay, but is that going to be the only... I don't think that'll be the only error. And I wasn't even showing the IDE for the last couple of minutes. Sorry about that. Alright, well. Okay, we got the right answer. The problem was... Let me just show what the problem was. The problem was... I had X's there instead of Y's. I managed to get this whole thing correct. But just this line right here, I put X's instead of Y's. Okay. Let me, That, oh my god, 1.5 hours to do part one? That's shameful. And this is, academically speaking, one of the easier part ones, because this is what you would actually solve back in GCSE maths in the UK, British secondary school system. This is just basic equations, right? So, shame. Very shameful. Okay. But it's efficient. Alright, whatever. Part two. Upon further analysis, it doesn't seem like any hailstones will naturally collide. It's up to you to fix that. Ah, so their paths collide, but they don't collide at the same time. So T1 is not equal to T2 for any of these. Right. You find a rock on the ground nearby. If you throw it just right, you should be able to hit every hailstone in a single throw. You can use them probably magical winds. Okay, I sort of get what they're driving at here. To reach any integer position you like and to propel the rock at any integer velocity. Now including the z-axis in your calculations. If you throw the rock at time t equals 0, where do you need to be so that the rock perfectly collides with every hailstone? Wait, what? Okay, this is not what I thought they were doing. We're choosing a trajectory for the rock. So we choose a position and a velocity for the rock. And we're in 3D as well. If you throw the rock... We need it to collide with every hailstone. Interesting. So here, we stand at position here, we throw the rock with this velocity, and we will actually collide with every hailstone. So we're not really extending part one. Part one was just a different thing, really. Okay. Oh my god. Okay. Oh my god, how do we get started with this? It's interesting. So the hailstones are... Okay, fine. Alright. I'm just going to put the kettle on again and go to the toilet so I can have a think about this. Alright. Alright. So... This is in 3 dimensions as well, so we're gonna have to rewrite our... Get collision code, but we can... Okay, that's straightforward enough. So we need to create a line that intersects every one of these points. So these points and their locations and velocities are chosen pretty specially, because this wouldn't normally be possible. Well, okay, if we chose a hailstone and said, okay, we need to collide with that at some point, doesn't matter when, then that already imposes a pretty tight restriction on our starting position, starting velocity, right? Because we're throwing in 3D space, but there's just this one-dimensional line segment. It's not even a full line, it's a half line. And we need to hit that line. So that already imposes a major restriction on where we can be. So you would think, after looking at all the points, that would narrow it down a lot. But what exactly are we doing to narrow stuff down? Do we want to use NumPy here? Because NumPy would give us some quick ways of... We don't have to do this simultaneous equations things. We can use the Gaussian elimination built into NumPy. Probably a good idea. This is horrible. This is literally just in one line in NumPy, just, I don't know, inverse matrix of whatever. Should we try doing that? It'll be a bit of a learning experience, because I haven't touched NumPy in a long time. So that'll be interesting. So from NumPy, so import NumPy as np, install NumPy. Alright, could probably rewrite all this using NumPy because we can't work with this. This is horrible. Huh. I mean, it probably won't take me that long. Let's see, it's NumPy. We didn't even use floating point checks, so we don't need that anymore. I guess we're not using our own pos. We'll use the NumPy pos. So we want hailstones is going to store NumPy vectors. Okay, so we want pos is that. Okay. Let's just say x, y, y. z equals map int that vx vy vz equals that. Okay, hailstones.append, so we want numpy dot array, I suppose. Array. What do we do here? Just literally just type in x, y, z. In that case, we don't need to. All right, just to say int k for k in position.split. Don't need that line. Velocity will be t.split. Is that it? Okay, just block out all this. So this whole part 1 should really be a one-liner. I mean, that's what NumPy's designed for. We'll see. So that last hour and a half was wasted, basically. Okay, at least I practiced using simultaneous equations. Now, let's see it not come up again for the next 5 years. Total 1. What am I? Okay. Alright, so we've got array and... Oh yeah. The problem with NumPy is that there's a limit to the size of the numbers, but I think int64 is fine. It knows to switch to int64. And it's using, I guess, int32 for the positions. Okay. Alright, so let's rewrite part 1. We don't need this anymore. This is the first day in the last like week or so that we haven't used our custom pos class that we've been modifying every now and then. Alright, so part 1. So total 1 equals 0. So we go through them again. So we don't need to do all of this. Instead, we just say, well, no, we do, okay, we fetch the positions and velocities, okay, as numpy arrays. Okay, so how do we solve equations? And so it's we want, hang on. P1 equals pos1, which is a vector, static vector, plus, and then we'll have a scalar time multiplied by the vector vel1. So that's what it looks like right now. Similarly, we have the same for t2 vel2. That's what we've got. We want p1 and p2 to be equal. So as before, we say set those to be equal. Fine. Then what do we do? So I guess we want to rearrange this into the format matrix times vector plus a constant equals 0. That's the format it likes. So the matrix is going to be the oh man, still don't really remember any of this stuff. Okay. So we want to find t1, t2, which is we want to find t, which is a vector of times t1, t2 for when these will collide. Okay. So I think we want to put the velocities as a matrix then. So it's basically, we create a velocity matrix, V, and it's going to look like V, it's going to look like this. So Vt plus P, which is some constant, equals 0. So how do I get this format correct? So we want, so we've got, still a bit confused. I can just Google how to use NumPy to find the intersections of lines, because I don't think I know the syntax here for how to. Let's just Google, see if there's any tutorials on this. NumPy to find intersections of lines. Intersection point of two linear equations using the NumPy polyfit. That's what we want to do. No. Yeah. Yeah, okay. I'm just looking at some different tutorials, find out what different people have done, because I don't... Some of these seems like they're doing more work than necessary. I'm pretty sure NumPy can kind of simplify a lot of this stuff. Cross line. A lot of people are just writing out the stuff that I did, but that's not the point of using NumPy. No, come on. Somebody should be... NumPy.intersect 1D. Alright, this is good. Okay. No, that's not what we want. Oh, that doesn't even use NumPy, that one. Okay, so, NumPy solve linear system. Just do that. Linalg.solve. Is this... Yeah, this is... Okay, this is roughly... So you want linalg.solve a, b. A is your matrix, b is your constant. So we want... Hang on, so it's... So... okay. So it's, Alright, I think I sort of understand now. Let me just write this down first. Velocity 1, so velocity 1 minus velocity 2. equals pos2 minus pos1. That's our matrix. That's our formula, right? Let's try and write this in numpy. Okay, so it looks like this. Velocity 1 minus velocity 2. That's our matrix. And that is pre-multiplied by t, which is the vector, column vector t1, t2, equals, and then on the right hand side we have pos2 minus pos1. That is another vector, right? v1 minus v2. Yeah, that's it. Okay, that took me a bit long to understand. It's been a long time since I've used any sort of column vectors, row vectors. Okay, so now what? So if I want to plug this into... Okay, so numpy dot lin alg dot solve so it's going to be vel1 minus vel2. I assume that, yeah, that does coordinate-wise subtraction. But this is in 3D. Well, we can do it just for the fun of it, but we have to project onto 2D for part 1. Which... there must be a numpy method to project. Let's see. Numpy project 3D onto 2D. Projecting... No, this is more complicated than I'm trying to do. I'm just trying to discard the Z value. Can I not? Okay, probably you want to use... Can I not just use slices? So it would be... one? Well, 2. Like that? Alright, we've got to print stuff to see what's going on here. Oh, no, no, no. I'm slicing it wrong. Whoops, hang on. H, first 2 coordinates for H in hailstones I. All right, let me see this. Yes, it works. That's how you do it. Okay, you can use slices. I know there's probably proper functions you can use as well, but Python slicing works. Okay, so we want J. Okay, so that's how you project onto the first 2 coordinates. So you're discarding the J. All right. And now, yeah, that's velocity 1. Should we just call it V1? And P1, whatever. We don't need to keep writing out all this, so V1 minus V2. P2 minus P1. No, this is just a comment. All right, so it's V1 minus V2, P2 minus P1. I think at this point, I'm not too worried about solving the problem in time. I'm just getting to grips with numpy, but I'm probably going to need this anyway for part 2, so let's keep on with this. I might have to take a break for lunch, so this is just going to be an unfinished problem, along with 21. I'm just going to have to spend the whole of today, right into the night, finishing off 21 and 24. I want to be able to finish on Christmas Day. I don't know. Okay. Print solve. Now, when the gradient, what does it do when the gradients are... Array must be at least two-dimensional. Oh, because the matrix has to be two-dimensional, but... Yeah, that's right. Wait, what am I supposed to do then? That's one-dimensional. It's supposed to be two-dimensional. Wait, yeah. Wait, well, what's my matrix? Is it just... Ah! It's just this stacked on top of each other. So it's gonna be... So this is a column vector. A row vector. We just want this row duplicated, don't we? Because we're solving the same... Are we? No. Hang on. Ah. No. I've got to write this down again. Okay, v1t1 minus v2t2 equals p2 minus p1. That's the formula we've been throwing around a lot. Okay, fine. What is the matrix then? It's going to be... Hang on, t1, v1 minus t2, v2 equals p2 minus p1. So... Alright, I think I sort of get it now. v1 and v2 are the column vectors, so it'll be v1 t1 minus v2. Okay, how do you append these together as column vectors? So I want this, we shouldn't be doing this. It should be v1 is one column vector and v minus v2 is the other. So this, I mean, this is probably something just straightforward, isn't it? How do you append? Let's have a look. NumPy. Put arrays as columns. So I want to make a matrix. How to combine column vectors into a matrix. NumPy.array. Okay, so you just do numpy dot, so it's going to be array. Wait, do you just put them in like this? Do I need to transpose? Let me try that then. Cannot construct a D type from an array. A D type? What's it? Hang on, I think I needed to put them in a list like this. There we go. Okay. That's given me something. We need to check if we actually get the... Alright. Singular matrix. Yes, well, that's expected. I thought it would do something special when that happens. How do we avoid that? Okay. T equals... that. So do try except I don't normally like error driven logic. This is a naughty thing to do, but let's just do that. Right. So because normally you should only be printing errors when there's actually an error in your... Well, no, I'm not printing errors. It's just not very clean to use try except as condition. Oh, maybe some people do like to do that. I don't know. All right, so this is t values. Would we expect them to be that big? Maybe, I don't know. Wait, okay, try the small input again. .33, 3.67. Okay. Maybe it's right, I don't know. Let's finish up the code then. So we've got a T. What do we want to do with it? We want to say if... okay, so we want it to be strictly non-negative. If, and you know what, NumPy even has something for this, even though we could just do it manually. NumPy dot I remember there's something for this, which is nice. What is it? NumPy check all values non-negative. Oh. I thought there was a command for this. like to check if a array is positive determinant or whatever, or okay, this works. Let's do this. If numpy.any, so if any time value is less than 0, continue. All right. Can we just do all then? Or okay, whatever. If yeah, all t value is greater or equal to 0. Yeah, that works. And and then we could do this and np.all. No. Yeah, okay, so it's p. So it's p1 plus whatever. We don't have to do this using vectors. We can just say t0 times v1 is greater or equal to b1, and similarly p2 we don't need to do this for the p2 because well, yeah, less than or equal to b2. So if they're all okay, then we total 1 plus equal 1. So that is basically replicates everything we did, but it uses numpy, so it's probably more efficient and everything, but probably same efficiency as our code, but because there's overhead associated with starting up numpy if you're just doing it for small amounts of data like this. But part 1 0, fuck. All right, just print what we're looking at then. Print. Oh no, because I've got the old bounds. Hang on. What is it? 7. I wish they put it in the input. I have to keep manually changing this. 7. 27. 7. 27. 5? Oh, come on. Right, let's see what's wrong. It's doing something, because it's not sending all of them in, so let's see. Alright. If we get this far, I want to see what T is. I'm printing too much stuff here. Oh, no, T was printed there. Alright, so for the first one... Yeah, we don't need that. 2.33, 3.667, is that right? Well, we're more interested in the crossing point. Alright. I've been clicking run from the menu all this time. Shift F10 would have been quicker. Alright, 14.33, 15.33. 14.33, okay, that's correct. So it's just this line here that's... If all... P1... So P1 plus... T... What's T0? That it should just be... Maybe that's not how you extract values from an NumPy array. I don't know how you... No, it is. T0 times V1. What's T0 times V1? Is that how you multiply by scalars? T 2.33. Minus 2, 1. So it'll be 2.3 and minus 4.2.3. Yeah, that's... So the x value of where we arrive is... here, right? X and y values. No, we were printing this twice now. Okay, just show me. 14.3, 15.33. Okay. Why isn't it? Oh, it is adding 1. So we are getting this one. That's fine. What should the answer be? It should be 2. So what's going on? We want the third pair because that seems to be the one where... How many are there? 5. All 5 are passing. What? Okay, fine. Print T and P for all these cases. They can't all be positive, can they? See, look. No, okay, fine. So that's within the bounds. That's within the bounds. The first 2, that's what we expected. This one is definitely not. That one's 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 not. Why is it adding these 5s? Am I not using these alls correctly? P is greater or equal. Okay, whatever. Test. Print P and MP or B1. Do I not understand how to use this? That's false. That's true. Okay, print it here, please. So the ones that we're adding, I want to see the T's and the P's. Seven and 27. 1, 2, 3, 4, 5. Whoa, 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 whoa. Oh, but that's 0. Wait, that's minus 0. Point. Well, that shouldn't count. Also, these two collide at the same time? Let me try and figure these out. So what is that number? Minus 0 point... If it's negative, if it's a small negative number, it shouldn't be included. Should we say greater than? Okay. 2, 2. What is... Why? How did that happen? So only 2 of these should count. Alright, so one of these is wrong. 14.33, 5.3, 15.33 we know is correct. 15.66 and 14.66. There's no such collision. What? How did we get the right answer for the first pair and then everything else is wrong? Accept, continue. So it shouldn't be using T's from previous... Just in case it is. Oh no, continue doesn't... Hang on. No. That's fine, we can do it like that. I don't understand. We are 2.5 hours in and I'm still messing around NumPy trying to solve basic equations. Right, we're just gonna have to print the posers so I can compare them against. Alright, so it's going to be P1, P2. This is the time they cross and the position they cross. Alright, let's check these out. So that one we decided was correct. 19, 13, 30. 18, but the Z value doesn't matter. Wait, do we care if the Z is within? No, we don't. Okay. No, it's fine. I was worried we were setting the Z equals 0. We're not, we're projecting, so it's fine. Okay, so that line's fine. The next one, 1913, 2025. So this one, they cross inside the test area at, it should be 11.6, 16.6. We've got 15.6, 14.6. How did we get the correct answer for the first one? V1 minus V2, P2 minus P1. It's nice and symmetrical, so... T1... Do we maybe transpose this? Is this not transposed? Dot transpose. Oh, for goodness sake. Wait, so... I don't know whether it's supposed to be transposed or not. So it's... A numpy array by default is a column. So when you do array of numpy arrays, it puts columns. So you have to do transpose to get them as rows. I don't know what the defaults are. Okay, fine. That's correct then. We had to transpose. Okay, that was a headache, but we got there, and that code is now nice and simple. Wait, just make sure it works. And the big one. And now we can start working on part 2, which may not even need most of this stuff, but whatever. Oh, no, don't print all this stuff. Whatever. 17906 is correct. Okay. Thank goodness. Right, get rid of that. Get rid of that. Alright, so nice clean code. Now what? So using this, we can work in 3D. We can get a so that's part 1, part 2. We can We have to collide with every single... So that already gives us an equation with unknowns. That first line should give us an equation which imposes a restriction on our initial, our chosen position and velocity, right? So they must collide in 3D space. That narrows things down. If they collide, then this process... Alright, well, let's write out the define get get. Alright, so you could... Alright, we'll just... Okay, get collision times. Or intersection times, because they're not actually colliding unless the times are equal. So we want to, given an initial position, an initial velocity, and another position, another velocity. Alright, we want to know what the t values are. So, and this is in, so basically we're doing this. Mostly. So, try t equals... So it's the same as before, but we are using the z values. So v1 minus v2 dot transpose p2 minus p1. So that's the same. If it can't be done, return none. Okay. Then we get the intersection point, which will be the same for both, for all 3 dimensions. Well, yeah, for both points, for both trajectories. So we want... Actually, we don't need this t equals greater than 0. So it's okay if it's okay if t is negative. We just want to know what t is. Oh, and this part 2 has nothing to do with bounds, so we don't need this bound anymore. So we just don't need any of this. We just need just return t. Okay, that's the intersection times. Okay. So this might... So if we just test this out, let's say p equals numpy.array I don't know, -5. Wait. Just use 2 that exist, I don't know. P v equals... Okay, P1 V1 equals hailstone 0. Fine, just do that. Then just use the next one. Right, I want to see what their intersection times are for P1 V1 against P2 V2. So it could be negative. None. It's saying they have the same gradient? Oh, because it's 3D, isn't it? So actually there's a very low chance of them colliding. Fine, okay, but I mean the method works. It's just if it's 3D, there's very low chance of them colliding. That's what we expected. Is there a unique solution to this? Probably, yeah. Yeah, because you add up the x, y, z coordinates of the initial position. So there's probably not going to be multiple solutions. So we need to find... Okay, I think it's a bit of algebra then. So there is a position P. There is a position P, and it has a velocity V. And if we use this, then it collides with every intersection time. So can we find some equations for P and V, given this information? So let's just consider what has to happen for us to collide at all. Not only at all, but the intersection times have to be equal. So this, so that means, so that means, we have T, which is the inverse of the matrix, the V matrix, multiplied by P2 minus P1. And we need both, so that would give us 2 times. And we need T0 equals T1. So that gives us an equation, doesn't it? Should we try doing this then? So, What? Call it, we don't really want, I don't know what I want this function to do. We just want to investigate, so get collision. P1, V1, P1, P2, V2. But we don't even know what... Need to look at my algebra again. I see. Okay. So if okay, so t times v1 minus v2 equals pos2 minus pos1. Okay. I'm a bit confused. This is a... Is the linear algebra actually this deep, or is there a simpler approach here? Because we have so many constrictions. Maybe I'm trying too hard to use them all, but maybe it's actually... Okay, so there's a mysterious... There's a mysterious dx. Let's say our opposition is dx, dy, dz. That's what we're trying to find. Okay, it's fixed, right? And our fixed velocity is wx, wy, wz. That's fixed as well. So if we run this against every single hail and say that has to collide with a value t greater than 0, what does that tell us? It tells us that so some value t multiplied by our w minus the other value, which is going to be v, equals pos2 Yeah, I think I sort of getting it. This gives us it gives us an equation, doesn't it? In terms of D and so if D and W, right, are mysterious initial position and initial velocity, then if running this against every hail gives us an equation, but then it introduces a an unknown value t as well, but that doesn't matter, I suppose. So okay, let's write this down. Just write what I'm trying to say here. So basically we have this equation. Some value t, we don't know, ti, multiplied by w. Hang on, so let me make dw are fixed position and velocity that we're trying to find, alright? And we have an equation ti times w minus vi, that's the ith velocity, equals pi minus d. That holds for every value of I, except we don't know what the t values are, but those are more unknowns, right? So I suppose there's this unknown t that we don't actually know, but it's also fixed, I suppose. Vector of times of collisions. So t is non-negative. It's positive. All right. So we have these three unknown vectors, and we've got this holds for every value of I. So if that just gives us 1,000 simultaneous equations, doesn't it? Can you then just do something with that? I don't know what to do, how to do this. We've got 3 unknown column vectors. I don't know. I don't remember anything to do any of my linear algebra. Would it be this complicated? So, I don't know. It seems like that's all we need now to crack what D and W are. And T, we can find T if we want, but it's not. That's just a dependent variable. I can't think in terms of, I've got to draw these columns and rows, otherwise I can't really understand what the heck they look like. So dimension wise, so ti is a scalar, and that's multiplied by a column vector, which is w minus vi, which is also a column vector, right? And that's equal to pi, which is a column vector, minus di. Can we not? So P and okay, I just need to put this in the form of a matrix, and then we should have something that we. Hang on. So how do I? I think. Hang on. So it's. Well, my pen's running out. I can't work with this pen. I need a new pen. All right. Interesting. All right, I might be able to actually phrase this correctly now. How... The... Okay, so the matrix we want, I think, is... Wait, so when you... What do you... So the bits we don't know... Okay, so the... Hang on. D... D... V... T. Okay. And on the right we've got... equals P dvt. So our vector, our x, so in the linalg expression, dot solve, the right hand side is just P, because that's this value here. We move the d over, so the expression, the matrix, I'm not sure yet, but the vector, the unknowns are dv and t, so we can put them as like, I don't know, column vectors or something, I don't know. So dwt. So it's, hang on. This pen, D plus TIW minus TIV oh my god, need a new pen. PI. Alright. So we got the identity matrix. Hang on. Let's try and draw this. Okay. Starting to get this now. No, I'm not. Because T and W interfere with each other. This is second order. This is not linear. Ah, you can't use linear algebra here because it's literally not linear. T and your unknown. T is an unknown. Alright, whatever. New approach. How about something like simulated annealing? We pick a spot, we pick a velocity, we work out the... So, okay. Given... Given we want to find the... Okay, so they probably don't collide, okay? But we can quantify how close we are by working out the closest points on the lines. So basically we can spit out the find the closest. So there's two lines. Find the point where they're closest. And we output the distance. So ideally it would be 0, but it's not going to be 0 in general. So we output the distance between those two lines, the distance between the closest points on those lines, at the Hausdorff distance, whatever it is. And the vector t describing the times at which they... No, better yet, we produce two scalars. One, the distance between them, and two, the distance between the times at which oh, but we need t to be positive as well. just to be clear, we need it... Yeah, we do need them to collide perfectly. Okay. I'm gonna have to take a break soon. This is going nowhere, and... we need to find the exact integer, but we could still get that if we round, if we use some sort of simulated annealing process. So my idea is that we try and do some sort of, I don't know, some steepest descent kind of sort of thing, where we, because I don't understand the linear algebra approach. I'm sure there's enough unknowns and there's enough knowledge here to be able to pin down the place, but I just don't remember how to do any of this linear algebra stuff, so I don't know how to phrase the matrix. I don't think you can. If t is an unknown and t is being multiplied by w, then that means it's second order. So you can't use normal linear algebra. You can use at least you can't use this linalg.solve because it's not linear. It's not a linear system, but you could use something else. I don't know. But maybe another approach is just we quantify how close we were for a given vector. And then we kind of just try different vectors and try to make that measure of closeness as small as possible. And eventually we'll find the place where it's basically 0 for every time. So you get a score, which is the only problem is my scoring function. Okay, so we want sum of squares basically for the distance between the two lines. Okay, because we want the lines to actually cross. We want the difference between the times at which the points reach those that point of closest crossing. But then the third parameter, I want it to quantify how positive this is, because we don't want the t's to be negative. So what exactly do I do there? Do we just say, is it literally just the raw number of negatives in our t, and we're trying to minimize that? Yeah, you could do that. Okay, let's try this. All right, so we want to find the t for which the distance between the lines is minimum. No, I'll just look up the formula for this. I can't be bothered to do the geometry now. Two lines in 3D, where is the closest point between them? Distance between x1 is minimal. Okay, so blah blah blah. Why is this so hard to find? Okay. Linear inequality. We want to Oh my god, no one just gives a straight answer. Here we go. Geeks for geeks, we'll get it. Alright, shortest distance between two lines in 3D space. Okay. Parallel lines. You don't want to deal with parallel lines. Well, you can still get the distance between them. But we don't really... Alright. Okay, I see. Alright, so the formula, let's just write out the formula. So it's if they're parallel, it's a different formula. B times A2 minus A1 over B. That's not complicated. And then if they're non-parallel, B1 times B2, A2 minus A1. So alright, so if they're parallel, okay, let's do these two cases. We'll allow cases where they're parallel, except it will rarely come up, but whatever. Alright, so no, we don't want this. Alright. Right, define. Get closeness for a given D and a given W, and this will just run through the Hales, compute the score for all of them, sum them all up, and compute the sum of squares or something like that. All right. For a given D and a given W, that's my starting position, starting vector. All right, so score equals 0. So we want the position and the velocity in hailstones. Okay, for each of them, I'm going to do this separately. All right, so for if they're parallel, how do you check if they're parallel? Gradient, that means the cross product is 0. All right, how do you compute cross product? NumP cross product. So in 2D, it's simply, it's simple, but NumP.cross, okay. NumP.cross A and B. All right. If NumP.cross So W with V equals is all zeros. Wait, cross product is a vector or it's a scalar? It's a scalar, isn't it? NP dot cross. Two arrays of vectors. In this case, it'll be a scalar, but if it were matrices, we'll test it out. Wait, no. Oh, I see. All right. Okay. So, if numpy.cross, so we need if all numpy.all, so we want numpy.cross w equals 0. So if it's all zeros, then it's the parallel case. So we want the distance equals, so it's going to be position equals position plus time times velocity. Okay, so it's the velocity equals numpy dot norm. How do you get the going to be cross product, I guess. Okay, numpy dot cross. So we want v. It's going to be the same as w essentially, crossed with a2 minus a1. So that's the difference in positions, so pos2 minus, no, p minus d, yeah, that divided by, wait, so how do we find the norm of that? NP dot square root. Magnitude. What's magnitude? Is it m? Is it called magnitude? Is it called norm? What? Oh my god. Numpy magnitude of vector. linalg.norm. Got it. linalg.norm. That. Divided by... Why is this... Hang on. Divided by numpy.linalg.norm of v. Why is this unreachable? What? If np.all np.cross wv equals 0, is that the correct use of... How did I do it before? All p is greater or equal to b1. That's how I did the predicate before. Is it supposed to be equals? No, I don't think so. How is this unreachable? What? Print get intersection times. Yeah, whatever. Just take that out. Take all this out. How is this unreachable? For P, V, and hailstones. I'm confused. I'll try running it. Okay, closest D. What? If np.all... Is this not indented correctly? What? X equals 1. That's unreachable as well? What? If np.all... This is a boolean, right? Yes, should return a boolean. If... What? If this was instead... I don't know, D. It doesn't mind that. Oh, am I not allowed to? Okay, I don't know. Let's say cross equals np.cross cross. Is that fine? Why isn't it like that? This code is unreachable. Returns the cross. What is wrong with it? What doesn't it like about cross? It returns the cross product of two arrays. It returns an array. We'll just have to try running it then. This is unreachable too? I think it's just confused. Alright, whatever. Else, distance is defined by It's kind of this formula where, all right, so it's going to be B1, B2 is equivalent to V minus, okay, so it's NP dot cross, so it's cross I assume this is dot product. So NP dot cross with A2 minus A1, which is equivalent to the difference between the positions. So that's D, so P minus D. So that returns a scalar, right? Or yes, and then we divide by the norm of B1 cross B2. So it's going to be NP dot cross oh no just cross okay. Is dot product always positive? No, it's not. So we want the absolute value of this. Oh god. Alright, just print distance. I want to see if we actually get anything here. Alright. Print get closeness of, I don't know, just go for the first hailstones. And so it should be 0. Well, hailstones 0 0. Or just do this. Okay, just... Alright, it's actually done something. And for the first one, it's 0. Perfect. That's convinces me that this actually works, but who knows? Alright, whatever. The IDE doesn't like this for some reason. Doesn't matter. We're doing it anyway. Alright, so that's the measure of closeness. Alright, so that's how close the lines are. So you want score plus equal distance squared, because we want to minimize the sum of squares. Or well, no, we probably won't put it all into a vector for now. We can worry about score equals list score dot append that, right? Return score. Okay. It's big numbers. That's fine. All right, so the first thing we put in there is the that distance. All right, what was the other thing we wanted? Oh, the time at which they reach that distance. It would have made more sense to compute this first, then we can get the distance pretty quickly. Should we try just working off just this scoring function alone? I mean, I would like the other things as well. Oh, okay. The other thing I want is the, we want the times at which they are. Intersect. Don't worry about the time. Okay. So that's distance. Between lines. And then the other thing I want in my scoring function is the... I don't know, it doesn't matter. Just do this for now. Return just sum of z, well, x, 2 for x in score. Alright, just return the sum of squares. And now we want to do some sort of walk, where we keep changing d and w. Now this is the... how do I do this? NumPy should have something to do this. NumPy. It's basically a non-linear solver. For custom function. Find the roots of a function. We're trying to find... Let's try using this non-linear solver. I don't think it'll get anywhere. Let's try it. It's still sippy. But we've got our function. We're trying to find... can we... Okay, so... Start equals, let's say, just, I don't know, numpy dot array 0, 0, numpy dot array 1, 1. That's where we throw the ball to begin with. Start, pause, start, velocity equals that. How do we put these into a matrix? So matrix equals numpy dot array start pause start velocity print m. Okay, so that's the row. Alright, how do you get them out again? You just do M0 or whatever? Yeah, okay, got it. Alright, so we put in an M as a matrix and dw equals M0, M1. Okay, now this nonlinear solver will try to find the matrix which minimizes this score value. Or get as close as possible. So we want... So it's going to look like this. Root equals fsolve. So my given function is going to be get closeness. Find the matrix. So my starting array will be M. What parameters does it have? Factor, band, max, val, full output, prime, Jacobian. We'll just leave it default. How long does it go for? I don't know. Huh. Takes one position argument where two are given. What? Get closeness takes one. Oh yeah, this is no longer valid. Okay. Axis -1 is out of bounds for array of dimension 0. What? Are these not the right dimensions anymore when I extract them from the matrix? Zero, zero? What? I don't know how to work with matrices. M should be a two-dimensional array. 0, 0, 1, 1. D... What? How did it change to 0, 0, 1, 1? Hang on, let's have a look. Print M. M is a 2D matrix, and then it gets turned into a 1D array? Okay. Fine. Can we just, Oh, but this is supposed to be 3. Was that the problem? Zero 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 111. So why does it get turned into a concatenation? So M gets passed into that. Fine, concatenate it if you must. I don't know, just Alright. Fine, whatever. M equals just do this. 0 0 0 equals numpy dot array 0 0 0 1 1 1. Alright. Okay, print M. And then we solve using M. So here we just take M 0 to 3, and here 3 onwards. Alright, will that work? There is a mismatch between the input and output shape of the func argument. Get closeness. Shape should be 6, but it is 1. What? Does fsolve know the dimensions? Fsolve. There is a mismatch between the input and output shape of the func argument. Get closer. Shape should be 6. Is it expecting... Oh... Well, our function is a one-dimensional function, but is expecting it to be 6-dimensional. Am I using this all wrong? Returns a value of the same length. What the heck? Okay, I don't know. Numpy dot array of that times 6. This is kind of stupid now, but apparently it's a it's a function that doesn't return a scalar. Okay, it wants to return 6 parameters. Okay, try and find. The iteration is not making good progress as measured by improvement from the last 10 iterations. Yeah, whatever. Alright, fine. Let's start closer to... Let's start a bit closer to the actual Hales then, because I think we're just too far away. Like, we can't start at 0 0 0. M equals, so it's gonna look like this. Oh my god, why is it so slow? It's not running. Alright. and then okay, try that. We're starting at one of the hailstones. No, there's no hope. This is too... that's ridiculous. No, we can't use a non-linear solver for this. It's asking a bit much. Alright, I don't know. Spent too long on this. I need to take a break. It's been 4 hours and I'm not making any progress with part 2. I've got 2 problems I need to try and finish off today. Interesting problem, but I don't know much. I don't remember much linear algebra, so I feel a bit stuck. Unless I've gone completely in the wrong direction and shouldn't even be worrying about linear algebra. I don't know. I feel like you're supposed to, but maybe you don't. I don't know. I'll think about this offline. Maybe I've got to forget linear algebra and just try a different approach, like some sort of... Everything brings me back to the idea of hill climbing and stuff like that, but that's all linear and non-linear. This is non-linear system, isn't it? Because of the time. We want the times to be the same. Doesn't matter. All right. Guess I'll be back on later today. Welcome back to Advent of Code 2023, day 24. I already started this earlier, but couldn't finish it in 4 hours, so let's carry on. This is a nasty problem. I looked up a little bit of discussion from some people. I tried to avoid spoilers, but at the same time I wanted something to point me in the right direction. So apparently, well, my instincts were correct that it's a non-linear problem, so you can't just solve it using linear algebra. So the 2 or so hours I spent on linear algebra were mostly fruitless, or at least I suppose I could use it. Hi DIJ, by the way. Yeah, so I'm already 4 hours into this problem, but I have an idea for how to continue, so I might be able to finish it off quickly, because I've already got most of the important code. It's just... we need to... So it's a non-linear equation we're trying to solve. So you cannot solve it in a reasonable amount of time in general. So it's one of these cases where the input has been specially set up such that you can solve it if you're just smart about it. So one thing I saw a lot of people mention, which I don't really know much about, is Z3. Apparently people solved it using Z3, which is a constraint solver program, software, developed by Microsoft, but there's like a Python module for it. It's a very powerful constraint solver, and it's reasonable to use to solve advent of code, because once you know your constraints and your equations, you know, then it's you've got the theoretical stuff out of the way. Then you can just plug it into a solver. I mean, mathematicians and computer scientists do that all the time. So it's not like it's not cheating, and it's not counted as AI either, because it's not actually AI. All right, but there might be a way to avoid going down that path, though. The other thing I could do is because. So as I said, it's a non-linear problem, and that's because of these times. So I could just make it a linear problem by fixing the starting velocity, because then you're not multiplying time by velocity, and then you've just got then what would we do then? So if we fix the velocity, then for a given hail, I can find a constraint on the position such that we collide with... Hang on. Yeah, this gives us a constraint on the position. Right. I need to write this out. And it's a linear constraint. And we would get one for every hail. So okay, hang on, let's comment out some of this stuff that we're not using. So my idea is, let's try fixing the velocity. Let's say let's just pick W equals array I don't know, it's 1 1 1 basic velocity vector. So we want to find a method which get starting position given a velocity vector if there is any such position that would work. So then we can use this. Okay, let me write out some stuff here. This should just be a standard linear algebra solver then, shouldn't it? So all right, let me write out the equations again, refresh my mind. Okay, so we have a fixed. Well, we don't know what. Well, yeah, we've got a fixed velocity vector. All right. So for a given hailstone, the equations are. So we got P1 equals the initial pos 1 plus T1 times velocity 1. That's just the displacement equation. Okay. And well, the equation for our trajectory that we're throwing, let's start with that. So that's going to be D. We're saying D is the position we're trying to figure out, plus T1, and T is an unknown. T1 times W W is, we're going to fix W, so in this case it'll be 1, 1, 1. Right. And then okay, so P1 equals D plus T1W. All right, and then P2 equals pos 2 plus T1 VI. Okay, those are the two equations. All right. So we want P1 and P2 to be equal. So D plus T1W equals pos 2 plus T1 VI. All right, so then what? Move all the D's and T's onto one side. So D plus T1 W minus VI, and then the constants on the other side. So that's getting into the form we want. All right. Okay, I'm starting to see. Okay, and then we want a matrix. Ah, so I think the problem was I wasn't realizing that you're supposed to sort of concatenate the D with the T. If you have D's and T's you want to find, then you put them as one big vector. Okay, T is going to be a big one, D is a small one. D is only 3 variables, and T is the big one. That's the other unknown, the times at which the things collide. So we want the identity matrix for the top left of this matrix, because that's going to be multiplied by D. And then we've got a bunch of zeros. Hang on. I'm not sure that I'm doing this right. I still don't get the linear algebra. If you knew... I just don't know what the matrix would look like. D1, D2, D3, D1 plus... Oh. Okay, I'm starting to get it. Hang on. D1 plus... Hello, Amaro. Still didn't manage 21. I haven't tried it since the last time. Oh, there's a mosquito flying around my desk. No, I haven't had the time to try it yet. Maybe tonight, because tomorrow's the last day. And this problem's... I don't know, I've been trying to use linear algebra to solve today's problem, but I think it's fruitless because it's a non-linear problem, so... We can convert it into a linear algebra problem, but then it's a bit confusing. Okay, I think I see how to do this now. W minus VI. Hang on, no, I don't get it. Wait, E plus... Alright, hang on. I'll put this in code, in comments, once I can actually figure it out on paper. W. Alright, I think I can write this in code. Hang on. So we got we need the matrix. And the matrix is fixed. No, it's not. Because of the W. The W is changing. Okay. So let's write out what the matrix would look like in general. Okay, so just make a bunch of rows. So for I in range n, so the first row, which is the x row, will be 1, 0, 0 plus, and then it will be W minus, okay, so it's going to be W zero. Okay, so and then the remainder of the row can't do this in one line. So the right hand side is going to be a bunch of zeros times n. Now we need to configure this. W on right hand side of we need to make new lists each time because otherwise this is gonna cause issues. Okay, so right hand side is a zero vector. We want the ith entry of this. So it's going to be right hand side I equals W dim, so x, y, z, minus the ith velocity so velocity it's going to be going to be hailstones, the ith hailstone, the second parameter, We want the x dimension. The XYZ dimension. Wait, is that it? We don't have zeros for the rest of them? Yeah, I guess so. Left-hand side equals 0, 0, 0. Left-hand side dim equals 1. So we create the identity matrix for the D's. And then rows dot append concatenate these together. LS plus RHS. Okay, for row in rows, print row. What does this look like? So it's always going to start with 1, 0, 1, as that's the identity. And then in the top left, we're putting the these are the coefficients for T1. These are the coefficients for T2. These are the coefficients for T3, and so on. Is that right? Let's hope so. So that will give us, and then the mat will be mat equals np dot array rows. Is that going to be the format we want? No, yeah, nice, okay. And then, so we want to get, if we're doing get starting position, for a given W, hang on, define update mat with a given W. So that means we do this again, but we don't have to build the whole matrix. We just do this. So it'll be mat. So for a given row, I mat I, that's the row, and the entry will be I, no, the row will be I plus dim. The entry will be I plus 3. So this quickly updates the matrix. We don't have to rebuild it every time. It will be this. So let's take this out. So we start with just zeros. And let's make sure we still get the same matrix. No. Where are the numbers? Mat, I plus dim, I plus 3 equals... Is that not how you update? I'm gonna have to look this up now. NumPy array indexing. Oh. If we do this, that creates a copy. So that doesn't do anything, but if we change this to comma, then we're accessing the location of the matrix. No? What the... Oh, I never called update. Goodness sake. Update mat W. No. What? W is that. Looks like everyone's giving up today and using external solvers. Well, I wouldn't call that giving up. That's a completely valid way to solve it. I mean, that's what programmers do. Mathematicians and computer scientists and programmers, they use... Because solvers aren't really AI. They're just, like, using algorithms like, you know, like steepest descent and stuff like that. So it's just shorthand for having to write out the whole of steepest descent algorithm yourself. I might try that, but I'm trying this one approach. I'm just first. Why doesn't it up? Oh, I don't understand NumPy. Mat, I plus dim. So which... Why, is it not doing anything? See, those are numbers. So why aren't those numbers going into the matrix? Is it static? Are we not allowed to change it? Okay, NumPy change value in array. A21. That's the correct way to index it, isn't it? So, mat, update mat. Print this. What coordinates am I trying to change? So I'm trying to change all these coordinates. Why doesn't it change? Mat 0, 0 equals 5. Alright. Is that gonna work? Yes, that works. Mat 0, 0 equals 5, but mat any of these doesn't like it. Do I need... Yeah, the zeros. I get that. Dim minus... Okay, and print it after. So I'm trying to change that mat location to that. Now show me what mat looks like after. Huh? Correct. Then why does the final printing... Print the first row. Maybe... Oh, it is changing. It's just the printing is not showing it because... Okay, fine. Maybe it's actually working. It was working all along. It's just I don't understand how the printing chooses. I thought the printing would show the non-zero values or something. Okay, fine. Fine, it's working. Alright, so my idea then is, okay, for a given starting position, we update mat to that position. Alright. And then we have to solve np.linalg. So we use this matrix, mat. And then the constant will be so we have to take the pauses. I think you just concatenate all the pauses together. How do we do that? Alright, gotta look this up. NumPy. Concatenate arrays. np.concatenate. Oh. So you concatenate. I'm gonna have to test all this out. I don't trust any of this. So the right hand side constant, let's call it ax equals b, equals numpy.concatenate. So it's going to be h0 for h in hailstones. All right, print b. All right, so just get starting pause w. All right, let's try that. I want to see what b is. It's a one-dimensional array with all the positions. Let's check. So 194, 332, 196, 194, 332, 196, and then it concatenates. So it's then 119, 151. Perfect. Oh my god. All right. Now stop printing so much stuff. We solve the matrix, this matrix, and this constant dot solve and that will give us dt. It'll give us both the d's and the t's. And most likely it will be unsolvable because we chose initial velocity that... Oh, what? Last two dimensions of the array must be square. What? Last two dimensions of the array must be square. What array? Which array? There's two arrays here. Both? I don't think so. B is normally a column vector. Mat shouldn't need to be square, should it? I don't remember how to do this stuff, but I thought you just supply a mat, and if you have more rows than necessary, that's fine. Some of them are just redundant, but the Gaussian elimination process takes care of that. Do I actually need to make it invertible? Huh. Maybe. Oh, I don't remember any of this stuff. Maybe I'll go down the solver approach. I'm sure this can be made to work, but let me Google this error. requires A to be square. But then... Oh. Well, it's not square, so this can't be done. The height is 3n, and the width is n plus 3. Should I discard? Should I just discard the bottom rows? I bet it's still solvable even if you discard half the rows. Basically, we've got more rows than necessary, and that means we have more constraints. So that would indicate that the first n plus 3 constraints will probably solve it, and the remainder don't. Oh. Hello, Tempo Alex. Thanks for the raid. Oh, I am really struggling with linear algebra. I'm about to try switching to using a solver, a non-linear solver, because this is... I don't remember any of this stuff. Okay, so I've got a matrix where I have more rows than columns. So I guess that means that, yeah, I have too many constraints. I thought the solver would just know what to do in that case. So I should just discard... If I just discard a bunch of rows until we have n plus 3, that's probably still enough to solve it. So let's try. How do I do that? Just literally just the IN range. So we go rows n plus 3. So I've just discarded 2/3 of my rows arbitrarily. I mean, if there's a unique solution here, that's probably fine, because it's very specially crafted solution, so the matrix may still be invertible, I don't know. Now try running it. What's this? Input operand 1 has a mismatch in its core dimension 0 with goofunc signature mm to m to m. Size 900 is different from 303. What is that? Size 900, it is different from 303. Goofunc. Oh, I think A doesn't match up with B anymore. Oh, of course. So the P value on the right hand side, we also have to discard a bunch of rows, because then the right hand side of the equation doesn't have. Where's my P? B equals that, but we need to Can we discard? Oh, I don't know. Do this with Python code. I don't know how to do it with NumPy. Just call R equals that. No. R equals. Can you take a sum of lists in Python? Oh, I don't know. Just R equals an empty list for H in hailstones. Yeah, I think my backup plan is to switch to Z3. So Z3 is a as I understand it, I don't know much about it, it's just a very powerful solver, non-linear solver, produced by Microsoft or something. And there's a Python module for it. But it solves constraint problems, which is basically this. You just need to, each row of, well, in this case, each row of my matrix is basically a constraint, so I can just plug them in instead of trying to make a nice square linear matrix. All right, I'll have one last attempt at this, otherwise I'm about to give up and switch to Z3. So basically Z3 would do a lot of the work I'm trying to do right now by hand, which is trying to fiddle around with the matrix, discard rows, stuff like that, but it does smarter stuff, I guess. R equals R plus H0. How do you turn a numpy array back to a list? Can you just go list? And then B would be numpy.array this big list. Print B. Alright, I want to see what this looks like. Okay, that looks correct. 194, 333, 196, 119. Yeah, okay, it's concatenating them. Now, just discard everything up to n plus 3. I think you can take a small number of these hails and still find the unique solution, because it's a pretty tight constraint to collide with every single one of these hails. So you probably, I bet you could do it just by just using like 5 of them or something, or maybe even fewer. Checking 3 hailstones is enough. Yeah, I guess so. So probably this is massive overkill, even bothering to use a linear algebra solver in the first place. I just write out the XYZ equations. I don't know. Let's see if I can finish this. So, oh, we actually got an answer. Okay. Okay. What did it give us? DT. So D and T are concatenators. So the first 3 entries should be the position it wants us to place our thing at. And then the remainder of the times. Okay, fine. Now what? We need all the times to be positive. So if we see any negatives, interesting. Okay, so this is basically saying if I just provide a fixed velocity, then then it's saying we should set the distance to the initial position to be that, and then the times at which we'll collide with the hailstones are these. But really, will it really collide with all those lines? I don't think so. Because in general, 2 lines in 3D are not going to collide. There's like a 0 chance of them colliding. Okay, I don't think this will... What does this actually mean then? But the matrix is invertible, so what? What is this telling us? What would... So with this velocity... Alright, let's assume this is correct so far. It's just we've got negative times, which means it's not a valid solution, but it's found, it's decided on an initial position. So now, my idea now was just to just try all velocities. I don't know, just spiral outwards from 0, 0 in 3 dimensions until we hit a velocity. Because I don't think, because if you look at all these velocities, they're all really small values. So I think that's probably the key. I think the answer velocity will also be small values. So I think if we just try, I don't know, but we're running this linear algebra solver every time, but whatever. So I don't know, for x in range, let's say, I don't know, let's try 300 for now. I'm still very suspicious of this, but the fact that it gives an answer is a good sign, at least. For z in range 300. So w equals numpy.array x, y, z. dt is, tries to solve, oops, no, what am I doing? So dt equals get starting position of w. All right, now what? We want all times to be non-negative. So numpy.all t equals dt from 0, 1, 2, 3 onwards. Okay, extract the t. Numpy.all t is greater equal to 0. Would it ever collide immediately? I don't think we should allow that. I don't think the situation will be like that. So if all the t's are greater than 0, print sum of the first 3. Print dt as well. And I guess there's a way to make it linear so you don't need a solver. Well, that's essentially what I've done here. Whether this is right or wrong, it's definitely linear. Because linear alg is solving it. I just don't know if it's right, but I've discarded a bunch of rows, which feels weird, but I guess, as you said, you don't need many hails to get to solve it, so yeah, that sort of makes sense. Print. So we need all t's greater than 0. Break out of this. Well, that would just break it. Oh, yeah, it doesn't matter. All right. Have you already solved it, Umaro? All right, let's try running this. Doing none type. Okay, if it's none, we just skip it because that means it was parallel or something. I don't know. Yeah, because if it's parallel, then it's not going to be solvable, is it? So dt, let's do try dt except return none. Hey, I never actually returned any value here. Return dt. If dt is none, continue. All right. How many values are we getting through? I should print something. X equals 0. Oh man. Should go a bit smaller. Solving these matrices every single time. Should I just discard way more rows? Like, just keep the first 10 or something. All right, let's make smaller numbers. So go to, I don't know, just 20 for now. I just want to see kind of what this looks like. Okay, let's make some variables here. Radius equals 20. And cutoff equals n plus 3. Alright, just move everything up here. Stop. Okay, so these are the hyperparameters. Why is this here? Get rid of that. Alright, see if we can just complete something. 0, x equals 0. So that's okay. Cutoff. Let's make a smaller cutoff then. 10. Index 10 is out of bounds for axis 0 with size 10. What? 10. No, damn it. This needs to be... Oh, these numbers are wrong. Hang on. Interesting. 3 times I plus dim. That should be 3 times I. That should be I plus 3. Right, that's still gonna have the same error, but okay. Row num equals 3 times I plus dim. If row num is greater than Cutoff. Greater or equal to cutoff. Don't do anything more. Okay. Alright. Didn't find anything. Fine. Let's increase the numbers. It's going to be in the hundreds probably. But... cutoff. Leave the cutoff alone. Radius... Alright, 200. Go for 200. Let's see. $100. Go for 100. Right, it might take a while, but I suppose I should really be doing a not iterative deepening, but just like just spiral outwards, or how do I do that easily? Just so we do. So like Z counts from 1 to infinity. And oh, I'm not doing negatives. Oh, this is not gonna... Damn it. Hang on. We need to change this. We can't miss out the negatives, can we? Negative radius. Up to and including radius. Yeah, there's probably going to be negative values in this, so... Alright. So we're trying for 100. Let's just see what it does. Oh, man. This Yeah, that was a mistake there, because 3 times I... I plus 3, column I plus 3, row 3 times I plus dim. Right, let's just write this in an infinite way. So we can say we want count, don't we? For, let's say, k in count, starting from 0. For x in, we need to import count from itertools. For x in, so negative k and k. For y in, and then y will go from range minus k up to k plus 1. For z in range minus k. So this will count outwards infinitely, but we won't repeat any. Yeah, so x will be minus k, k, and then so go 0. Okay, we'll repeat 0. It doesn't matter. then -1, 1, two, -2, 2, -3, 3. X will follow that pattern. And for each of those, Y will range from -k to k. Alright, so this is probably the way to do it. Print k. So we know roughly what magnitude we're getting to. Alright, just do that then. So if our solution is somewhere in the first hundreds, then this might actually get somewhere. Right, so it's going to slow down. So that's kind of ensured we've done all of the 20s, or at least all of the velocities where x, y, and z are all at most 20 in magnitude. Now it slows down, but at least we know if it reaches a point, we'll actually see something. It's not gonna stop. We'll have to stop it when we see something happen, but it will print dt and the sum, which is what we want. And we've left the cutoff at 10, but we could reduce it even more. So Mario said 5 will do. Should I make it 6? Yeah, let's reduce the cutoff. Let's see if we actually get a result. Alright, we'll make it 5. So that's basically like... Oh, no. If I need 3 hailstones... Alright, well, no, we'll try it anyway, see what happens. If I need 3 hailstones, then I need at least 9. But it's not finding an answer, so it's not like we're going to be bombarded with wrong answers. It's still too slow there, but... I don't even know if this equation is, well, not this equation. This equation is, this matrix is even correct. I gotta look at it again. 1d dx plus gi So when I updated, so yeah, it's w, so x, if we're in the x, then it'll be 3 times I, yeah, wx, and the x value of the hailstone, the ith hailstone, 1 is the velocity. And then the position is the right-hand side, b, np.array r. Why are you assuming velocity will be low? I'm just praying it will be low. Because all the other velocities are low? I don't know. If it doesn't work, then I'm just going to go to Z3, because what else can I do? Spiral outwards at low velocities. We'll eventually get there, but it'll only get there if the velocity's low. I don't know what kind of situation this is with these hailstones, what it looks like. Are they all like in a pattern? Alright, so now it's really grinding to a halt. Come on, can we get to 100? I don't think so. It's still climbing. Alright, we'll go to 100. Meanwhile, I can look up Z3. What is the name of the Python module? Z3Py. And copy paste what someone on Reddit said about making it linear. Yeah, you can if you want. You can see if it's anywhere near what I did. If the rock has position and velocity PO and VO and the hailstone's PI and VI, then we know that PO plus TI times VO equals PI plus TI times VI. Yeah, that's exactly what I have written down with different letters for every I, and so PO minus PI times VO minus VI equals 0. Wait, where does that come from? Is that a cross product? PO minus PI equals minus TI times VO minus VI. Alright. TI is a scalar. PO minus PI and VO minus VI are parallel vectors which have a vector 0 cross. Yeah, okay. I see. Fine, I agree with that. So then, it's not something I would have thought of, but yeah, I guess this is just one of the things you do when you do linear algebra. You okay, so then, so that okay, so the cross product is 0. So I guess that gives you... Huh. Yeah, that's much better than what I'm doing. In terms of number of equations. Wait, so it's 6 by 6 system of linear equations for P naught and... I see. We're in the hundreds now, but... so I could go... Well, let's try the Z3 thing first. That might be easier. Well, and yeah, I understand that description, but it's sort of like, I don't know. I wouldn't have thought of going down that path. So, it probably won't help me understand how to tackle that same thing in the future. Alright, I think the Z3 might be more useful to future advert decode problems. Let's see. Z3 prover. Z3 solver. Okay. So, what Z3 solver? Wait, no, it's not gonna have a hyphen in it. It's what's it called? Wait, it actually does have a hyphen in it, but it can't. But I think. Hang on. Let me use the package thingy. Can I just remove that? Alright, let me just search through the packages. Set. Gotta install it first. Yeah, that's what I'm doing. Well, I'm using the IDE, so if you just write it here and it will install it. But it's not finding it, so I guess it's called Z3. Ah, okay, I've installed Z3. Is that the right one? Not Z3 solver? Alright, so we've got Z3. Z3 dot... What do I do with it? From Z3.Z3 import int solver sat. I see. From Z3 dot Z. Init.py. Okay, let me check the packages. It's installed something called Z3, but I don't know if this is the right thing. I see. Alright, let me remove that for now. And add new package, Z3. There we go, Z3 solver. Specify version 4.12, 4.0. Oh, I see. Z3 by itself is backup ZFS snapshots. Alright, let's remove that. Remove. We want just Z3 solver. Alright. Does it find these things? Dot Z3 import ints. Okay, it's working. Oh my god, now what? Well, I suppose every line of this matrix I made that I can just put as a Z3 constraint, just let it deal with all that mess. So basically what you've written there in chat, Umara, the first part, just the P0 plus so-and-so, I could just put that in, I suppose, and not worry about condensing it, see if Z3 just does it. I don't know how to, what kind of format I need for this. Let's get rid of all this. Alright. I need to look up what to do with Z3. Z3 solve linear equations. Solve Z3 solve system. I just want to see some examples. Solver. Okay. S.add. So I guess I just want to create ints for my, so d x equals, so it's going to be int dx, fine. So we want dy and dz. That's just like my displacement, initial displacement. And then we want velocity, I guess. Vx. Oh man, this is running slowly. It could find it if the velocity happens to be within 200. Like 200 was roughly where most of these lie within. I'll leave it running. Vx, Vy, Vz, Vx, Vy. By the way, Umara, if you're still there, I finished Doom yesterday. Oh wait, were you there? No, Wogger was there. So I'm on to Doom 2. I could do Doom 2 on Christmas. There's a Christmas texture pack. That would be fun. All the imps will be wearing Santa hats. I couldn't think of any actual Christmas games. Die Hard, I guess. And The Nightmare Before Christmas. My velocities were between -300 to 300. So this actually... Well, we're not halfway there because it's polynomially increasing, but we're part of the way there, I suppose. There's not many games centered around Christmas, are there? There's lots of Halloween-ish games, but not many. I guess it's not good to make games centered around Christmas because by the time you finish making the game, it may well be the summer or 2 years later or whatever. So you can't time it to be released for Christmas. So that's Batman Arkham Origins was set during Christmas. Shenmue was kind of set during Christmas. It was set during December. When you get to Christmas Day, it's all like town is all like Christmassy. All right. We need ints for what? All the other T's as well. I suppose so. Yeah. Okay. Or Vampire Redemption is set during Christmas, is it? Interesting. Wait, you're talking about the Masquerade, or... Wait, what's Vampire Redemption? Alright, so we want T in Vampire the Masquerade Redemption. Oh, I always get confused by these games. So this is the one that's still still to be released, or this is the game that's been around for ages? The really old one. Is it called Redemption? Bloodlines. Oh, so Redemption is a different game from Bloodlines? I see. Okay. So what? Redemption came before Bloodlines, or are they not related, or what? Ah. Okay, for T in... Okay, for I in range... times equals that. Let's just do this. Int T plus string I for I n. Alright, should I just stop the program? It's taking too long. Vampire's a tabletop game like Dungeons & Dragons. The video games are just using the rules. So the game you're talking about is a board game or a video game? Alright, so that's our variables, our unknowns. Now what do we do? I just closed the window I had. Okay. S equals solver. Okay. And then we do... Oh, interesting. Okay, that's how we do it. Right, so we have to... For I in range n, so we write out our equations. So the x will be, so it's going to be dx plus, no. So we do solver.add, s.add, okay, got it. s.add, and then we just write out the equation, the predicate. Dx plus t times I, assume I'm allowed to do it like that, times Vx equals pos, so it's going to be the hailstones. Hailstones. It's the ith. Hailstone. The position. The first parameter. Plus times I, this should be a equals, times I times, and then the velocity would be hailstones I, the velocity, and it'll be 0, okay. And then we just have to repeat this 3 times. So dy, dz, one, two, 1, 2. Alright, is that it? And then s.check, s.model. Alright, fine. Do s.check. s.model. Does that just print? Okay, just to see if this what it does. Wait, we need to stop all the previous stuff. Okay, switch all that off. The IDE is so slow, but I'm not even running it. It's running slow in anticipation. It knows I'm about to bombard it with there is no current model. So is there not just a solve method? s.solve, s. Well, what do I do now to just tell it to? My god, the computer's running so slowly. Hang on. If solver.check equals sat, then you can get the model. What's Solver.check. What's sat? Is that something I should be importing? Ah. And that's S, okay. So this needs to be run first before I can... If... Okay. S dot... Do I just run model now? Or print the model? So it's not. It wasn't satisfiable. Using Vx in all equations. Uh-oh. Uh-oh. Ah. That's stupid. Also, the other thing is I didn't check for t or all the t's being positive. All right, let's see if it solves it. But but then we need to put the constraint for t's to be positive. But maybe it just solves it without. Well, they're all positive anyway. I mean, there's going to be a unique solution. What's the d's? Okay. How do you extract from the model? Is it like a hash map access or m dot? Can I just Can I do this? Dx? Oh, I'm supposed to put the dx. Yeah, that makes sense. Alright, let's just write it all out then. So it's going to be A, B, C equals... I think this will be useful going forward for advent code stuff. There's probably some stuff that I can make simpler just by having a solver solve it for me. So it's going to be dx, dy, and dz. And you would think if it found anything at all, then that should be the right answer, because what else could it be? But you never know. Okay, it's still in the language of the model. I could just add these up by hand. Let's try and get it. What do you just A dot? Can I just extract an int from it, or... Oops, no, not like that. As long on each of the values. Aha, okay. Alright then. Moment of truth. This was a, well, at least I learned stuff from this problem, but... Oh my god. That's insane. So that took me just under 6 hours. That is like 4 hours of just faffing about. 2 hours of progress, essentially. Oh man. Yeah, I couldn't really manage on my own. I mean, I would have, but I would have just have to search lots of stuff. So yeah, thanks for the help. It saved me time. So yeah, what Omaro said about the smart way of doing it that doesn't use a solver, yeah, I sort of get it, but at the same time I can't see a path that I would follow to get to that myself. It's like, this is... I mean, maybe when I was back in university studying linear algebra, then I'd be thinking like a linear algebra person, but now as a programmer I don't go that deep into linear algebra anymore, so yeah, it's kind of hard to go back to that stuff. I never really liked linear algebra that much, even though I know it's supposed to be one of the most useful things for programming in the fields of mathematics. Especially if you're going into scientific stuff, fluid dynamics or computational physics, anything involving sciencey stuff. But yeah, either way, I guess you really had to have some level of linear algebra. Even if you're using Z3, you kind of had to, well, yeah, you kind of, the way you're phrasing your equations, that is linear algebra, sort of, except it's not linear, it's non-linear, but it's, okay, it's algebra. It's algebra. And I think my big old matrix method might have worked if I had let it run to a 300, which would have taken a long time. But then again, I don't know if that matrix was even correct or what. I don't know. Okay, 24. 12 minutes. 12 minutes to 1 hour, 2 minutes. So, tough problem. My leaderboard. Umaro's done it, and Sam has done it. So, Umaro, if you're still here, what did you use in the end? Did you use that linear approach, or you used the solver? Captain Coda. A few people have done it, not many. I don't feel like coding anymore today. I need to finish 21, but I don't want to code today. Maybe in the morning tomorrow I can try and finish off 21 before the problem opens, because I want 25 to be the last problem so I can close it off and get the 2 stars. I don't know. I'll figure out what to do today. It's been 6 hours of coding already. That's like That's more coding than I did when I was a full-time software engineer on a daily basis. Alright. Anything else I wanted to look at? Not really. It's now's about the time that Captain Coda starts coding. So yes, I started at 12 today, and then I took a break to go to the supermarket, and then I carried on, so that's like 6 hours. Yep. I think everyone's gonna struggle with this a bit, so... we can go and watch the Captain Coda struggle, maybe? I think my plan is to eat and then start streaming again. What, streaming more Advent of Code, or something less strenuous? Alright, well... let me just set up the raid. Still have to finish day 24. Maybe some Kerbal after that. Sounds fun. Kerbal the new one? Kerbal's 2 or Kerbal 1? I've heard mixed reviews about the new one. I don't know if it's good. The new one. Okay. But it might be a case of... oh, it's still buggy, is it? I thought maybe it'd be buggy on release and then they'd fix it up again. Is it still... the latest update made it playable though. Okay, interesting. That's a bit disappointing, but yeah, that's the pattern that's happening these days with these companies. They make buggy games and then promise to fix them later. It's a tacky way of doing things. Alright. Captain Coda. I'm gonna go prepare dinner and listen to Captain Coda struggle. I assume he'll struggle. We'll see. Thanks everyone for watching. And tomorrow will be Christmas Day, the final day, and then I'll be free for a year. So, see you tomorrow.